get started once again. Thank you very much for coming again. This is last but not least our last talk of this track today. It's a second talk about utilities and energy provisioning with OSGi technology. And I'm very happy to introduce you to Kai, who's been with OSGi for 13.5 years. And in addition to that, he's also the ProSyst evangelist. If you've seen the latest, the last presentation, you've seen that NW as a utility provider, as a utility is already using ProSyst technology. So Kai is from the same company and will provide you with a second utility now working with OSGi based on the implementation that is provided by ProSyst. So please welcome him.
All right, thank you. Okay, so the presentation is about OSGi as an incubator for the German Energiewende. So we have learned that this word Energiewende is also used in, let's say, in other countries. So we chose to use this word, but it basically means let's say the energy transition from traditional energy sources to renewable sources, and we see, let's say, smart home a big part of it. So the presentation is, let's say, prepared by Jens Lekamp from the PLab, who is not here today. So he did the slide that have a nice design. I did the other slides, and before I start, a short introduction to the PLab. PLab is a small company based in Oldenburg. They are experts in user interfaces, user experience, and they do a lot of app development stuff. EWE is one of their biggest customer, but they also work in the context of smart home with other companies. So we work together on this project, and so they are basically responsible for the whole user experience in the smart home context. Then short introduction about ProSyst. So we are a leading vendor for IoT middleware. We have been founded in 1997 in Cologne in Germany. And as you may have seen in Stefan's keynote, we are now part of the Bosch group, and we have been involved with the OSGi Alliance since the early stages, and we have been, especially in the context of smart home, very broad customer network and partner ecosystem. So the presentation is about energy of things, or to say it like this, to interface with things in the grid. All kinds of things, that's not just a smart home, and it also includes basically the user. So there is this G7 resolution that says that the global warming is not supposed to be higher than 2 degrees before the industrialization on Earth, and that means that we have to reduce heavily the CO2 emissions, and the energy or reducing the energy consumption can help to achieve this. Then the fact that we will have billions, we don't know how many billions, but we will have billions of connected devices in the IoT that basically are part of the grid or somehow connected to the grid, makes it let's say not easier. And in addition to this, we want to achieve by 2050 80% of renewable energy sources. So this is just another slide about the renewable energy sources. Today we have about 84 gigawatt mixed today from all kinds of renewable energy sources, solar panels, windmills, etc. and in 2050, we want to achieve 304 gigawatts. And there is a project, a research project that is, let's say, started by EWE. So I think the fourth largest utility in Germany, that basically has today already a problem with their energy network, at least in certain parts. So they have a lot of windmills in northern Germany, and in some areas they already have an overproduction of 170%. And that, can get them to the point where the network gets unstable. Yeah, so they need to get rid of the energy at some point. Yeah, and sometimes they need energy in order to basically keep the network stable, and have to buy basically from somewhere else the energy. And to balance this, they have two options. So either they increase the network, or they make the network more intelligent, and this is what they want to do. So part of, or the mission is really to digitalize the energy system and everything on the grid, from the windmill to smart home, and to go the next big step towards a sustainable world. And one of the ideas here is to use the design thinking method in order to achieve this. So it's not really about, let's say, the features, but it's also how it's actually be applied. So the project basically deals, of course, with a smart grid, smart data. So because we get a lot of data from the network and from the homes, and we have to deal with it, and a smart market. So basically, they want to have a marketplace from where you can, get, for example, additional value-added services for the home. The website of the project you can see here. It's, I think, still in German, but they are going to translate it. Is energievernetzen.de. And as I said, smart home is going to be a big part in the project. And the way they see smart home right now is it's too complicated. Yeah, I mean, basically, you as an end user have to be smart in order to, get your smart home system smart, or to make your smart home system work in the way you would like it to have. It's complex. It's fragmented. As you have seen, there are lots of different standards, lots of different platforms. And one of the biggest issues is it doesn't solve really a problem. I mean, you have feature limited devices, a thermostat, you have a plug and so on. But the thing is, you can buy them individually, yeah. And there are few ecosystems like what Stefan has presented, like Mosaic and Kibicon and so on, that basically try to integrate all kinds of smart home devices and sensors, etc. But today basically most of the devices you get are on its own, and they have an app to use it, and it's not integrated with anything. And then, as you can see here, X10, it's a 30 years old story and hasn't really progressed that much in comparison to that. Enera is all about creating new flexible business models. Information is a primary product. Based on this information, the idea is to create new business models. So basically, all the data you get from the grid, from the smart home, they want to analyze it and see, how can we, optimize, parts in the network, or how can we optimize, for example, the energy consumption at home, and how can we, make this more attractive to the end consumer, because that's one of the problems today. You can buy a storage, you can buy all kinds of, let's say, equipment that helps you to save energy, but it's too expensive for, let's say, the normal user. And we are trying to find ways that makes sense for everybody, for the utility who, let's say, can keep his network stable, for the end user who doesn't have to pay a fortune and actually can benefit from it and later on. For this we have a smart data and a service platform, and as I said, so it's a data and need-driven with data and need-driven services, and of course it's about an API for the energy of things. This is a quote from Albert Einstein: "We cannot solve our problems with the same thinking we used when we created them." I think that applies exactly here. Yeah. And so this is, let's say, how the project basically, let's say, sees the big picture, basically. Yeah. So you have the smart home system as part of the grid, obviously. And you need to, let's say, actually can serve as an interface to the utility, yeah, because today we don't have such an interface. The data we produce can be analyzed by a big data platform that actually can be used to create new business models, and based on this we can create new added value services that could then be made available via we call it Energiewende App Store. And of course this is not only for let's say the end consumers in their homes, but also for industrial customers. So ProSyst basically had to apply to become a part of this project. As I said, EWE is a coordinator, and they set up this project with like 75 partners. So it has an overall budget of 200 million euro, and they request 40 million funding from the German federal government. And so basically, when we applied to them, we presented, let's say, our architecture. You may have seen it somewhere else, but so the idea, of course, is that you connect with devices and sensors to a home gateway where we have an OSGi framework, and there can be all kinds of protocols. We abstract them, or we abstract the devices from the protocols. And we have a management system that allows us to do software provisioning, to do device management, and do this all in a, let's say, standardized fashion. So in order to create a smart home ecosystem, what they were, let's say, keen about was, so first of all, it should be compliant to OSGi Open Platform 2.0. I will explain this in detail a little bit later. We need device abstraction in order to keep, let's say, the barriers low for also small, medium enterprises to participate in this ecosystem. Remote management, we want to be able to manage the ecosystem, to be able to add new value-added services. Obviously, tooling is important. Yeah. So in order to create apps and to, let's say, also ease again the pain of developing apps for the developer. And as I mentioned before, UI, user experience, is another very important part in this project. OSGi Open Platform. So OSGi is an organization similar to, or not like OSGi, but it's an organization that was founded by many broadband service providers and equipment vendors. And they have defined a document that was called SWEX in the beginning. Now it's OSGi Open Platform. And they basically define a set of requirements for a software execution environment in home gateways. And most of it is generic, so it's not defining specific technologies on how to achieve this. And they have some requirements regarding lifecycle management, security, etc. And they have also an OSGi specific part for the requirements. And here they define, you know, what should be the Java version, what should be the version of the, let's say, used OSGi framework, which services are mandatory and how they have to be configured. So it's basically like, you know, best practices in order to get started to build an ecosystem for a smart home. Device abstraction obviously should be, you know, based on standards. We just released a couple of weeks ago the OSGi residential specification release 6. There will be another talk tomorrow, I think, before or just after lunch. And so it contains a device abstraction layer specification. So the idea is to, let's say, to make it applicable for all communication protocols, to have one API for the app developer instead of 4 or 5. Yeah? So in order to talk to Bluetooth or Zigbee or Z-Wave devices. Yeah? So you don't need to be an expert in either of the protocols. It provides access control based on user and application permission. So users may not have permission to do, let's say, everything. Yeah, the same for the application. They may not be able to change state of the heating device, for example. Yeah. And in addition to the device abstraction layer, we also defined a set of functions. So like a Boolean switch, multi-level switch, we call it. So basically some basic devices that can be used in order to build also higher level device descriptions. In this context, we should mention also that HGI is currently working on a so-called smart device template. So the thing is that the device abstraction layer is a nice to have, but it's, I don't want to say useless, but it's not intelligent enough. So it does not have descriptions for describing the devices. And HGI developed a template for which we can, the way the devices can be described. And they send it to different organizations and get it back and makes it then available to other organizations. In this context, we should also mention Eclipse Vorto. Stefan mentioned this earlier as well. Vorto helps us to create an information model out of device profiles and generate code for different platforms. So there are a couple of code generators already available for Cura. I don't know what it was. Olaf, I saw him. iOS, thank you. So we are working on a MBS code generator and some others. So this is very helpful, and that actually helps us also to get started today. Yeah. So we don't have to wait for a standard to provide us the description for all kinds of devices. Remote management. Obviously, it should be based on standards. Tier 69 in the context of smart home system is currently the standard. So it helps us to basically deploy new bundles and to change their configuration and stuff like this. And so ProSyst has a remote management system, as you have seen in the earlier presentation maybe, and this allows us to manage the OSGi environment on the home gateway. It provides a repository for applications and services. We can do software provisioning, device management, and can even do things like data synchronization. Obviously, we want to be able to manage certain assets. Yeah. So, like I said, we want to be able to get the data, push it to the backend system, and maybe give the data or provide the data to a big data system. In this context, firmware over the air updates might also be, needed because sometimes for security halts, you have to do this. And of course, since energy and smart home basically just one part, so we may have to integrate with other IoT ecosystems and backend systems. So, and here just as example, there might be, as I said, or there will be a big data system, but there might also be something like a BPM engine. So, UI, UX. So first of all, the design of the product is something that we want to be keen on. So this is just, let's say, an example. So it looks a little bit like a pot, yeah. But so the thing is, in here you have the hardware. It could be, for example, Raspberry Pi, yeah, and you can open this bowl, yeah, and can put stuff in there, yeah. So it looks nice. You may want to, put it on not on a table, but somewhere so it's visible, yeah. And it actually can also be helpful because if you enter the home, it can, light up and give you like a status, yeah. Or if you leave, it can, turn red and tell you there's still a window open or something like this, yeah. So it really, gives you, I don't want how to say it. It's nice looking and you really, like to interact with this. Then I think if you want to build up an ecosystem and you want to make it as easy as possible for all participants, it's good to have guidelines or templates in terms of how to build a user interface and how to, provide user experience. And then the project really aims to make, let's say, the smart home system smart, yeah. So not to, have the user figure it all out. So the Peak Lab and ProSyst have also been working in another project that we try to reuse here is a living lab as a service. And in this living lab, we try to also set up best practices on how to develop a system and to be agile about it, to involve users and to basically go step by step from a prototype to a final product. And I mentioned the last point already, so involving users is basically key in order to make sure that this system meets the expectations. Okay, yeah, I think that's the last point. Think big, start small, and do OSGi. And I think I'm at the end of my presentation. And if you have any questions, I'm happy to answer.
Are there any questions?
You mentioned remote management. If there are so many systems, what's about self-management? It's a system itself managed.
I mean, we are in an early phase, yeah. So we have not figured this out how this will be, yeah. But yeah, certainly that would be, something that could be of value for the project. But yeah, right now it's not really described in any way.
That device that you've shown 2 slides ago, does that mean you in the group are figuring out a generic thing that later on is equipped with separate useful things, or how is that? I didn't get the thing how that shall work.
You mean this here, right? Yeah. I mean, this is just an example for, how a home gateway could look like, yeah? So not like a router, something you put under the bed or, you hide it, yeah? So the idea is really, to show it, yeah? To make it visible and even benefit from it, yeah? Because it can, give you some status messages and stuff like this, yeah? So, so it's really, as I said, it's about the design and to enjoy it and, not to have something ugly that you put under, the bed or something.
cases you really like? So, I mean, there are thousands of use cases probably for all that stuff. Maybe you have some good things you can share.
I mean, so use cases is currently not really defined, yeah. So the project hasn't, let's say, officially started. But the thing is, we worked, for example, with Miele. So there is this Miele at home system, and they have so-called smart grid ready devices. And so what they can do is they can put the dishwasher or the washing machine in a so-called smart start modus. And by this, the washing machine basically waits for a signal from an external entity, could be utility or someone else, yeah, in order to start, yeah. There are other use cases that could be in case of if you have an overproduction in the network, that you charge, for example, a battery or the electric vehicle, yeah, for maybe either for free or for a lot less than normal, yeah. So that some ideas where this could go.
Question, you mentioned provisioning of the OSGi on, let's say, the gateway. There's this Rocket project, which is also from Bosch.
Right.
How does it integrate with your stuff? Is it completely separate, or do you use it already? Or?
We are working on, let's say, on the integration, and so the basic idea is that Hawkbit sits basically on top of MPRM, yeah, and could, let's say, control MPRM, yeah. But in this case, for the project, that hasn't been discussed yet. That's more, let's say, a current stage internally.
We're working for a telecom provider in Belgium to support their customer support. And they're confronted now with indeed all these evolutions to what they still call it digital home instead of smart home. And I was wondering if now this is coming from the energy providers.
Correct.
How would they work together or share responsibilities with the telecom provider, because all these connected devices running into a public network?
I mean, technically, that would be, I wouldn't say easy, yeah, but I think that's more a business problem, yeah. I mean, wanting to cooperate, yeah, and so for example, I know that KiwiCon is already cooperating with Vattenfall EnBW, so they basically use their home gateway and let's say the backend and everything, yeah, from Deutsche Telekom. So that's one possibility, yeah. In this case, there is right now no intention to work with Telekom, also because EWE has its own telecom network. So
Device.
that might very well happen, and that's where I think projects like Voto might be very useful, because I mean, if you have multiple home gateways, yeah, you still want them to work together, yeah, and then Voto could be like the binding methodology, yeah, because I mean they basically use the same theory. Use the same device profiles or information model.
Okay, me once again. With regard to the project in general, we are talking about enera now. As far as I understood it correctly, you're going focusing on various use cases and then see what the result out of it is. First of all, how long will be the project running? And second, are there any indications already that EWE or any of the other participants will provide, or based on results, provide offerings to the market?
A good question. So the project is intended to be, a 4 years project or 4 years duration. EWE as well as Devolo actually already have smart home offerings. So Devolo was also mentioned earlier. They have this home control product line that actually is using OSGi already. And EWE is basically using this system and modified it for its own use. And of course, the plan is to, based on the results, to continue the development of this product.
So it goes just back to this, right now it's more or less in the smart metering part, but I assume that also will really be an incubator for smart grid technologies?
Yeah, I mean, the thing is that we look right now mostly in the smart home part, but of course with an integration to the grid, yeah, and how to, let's say, provide value-added services there. I mean, the challenge is that the end consumer, you know, has to participate in this, and he needs to want it, yeah. And how to convince him? This is, the challenge basically, yeah. If he has to spend thousands of euros, then, you know, it's very unlikely. And the idea is really to figure out, you know, how can we, you know, get those people involved and to find new business models that make it basically possible for everyone, yeah.
One final round. Any further questions? Well then, thank you very much, Kai.
Thank you.